The summer course is a series of virtual, interactive lectures on topics related to responsible investing, consumer behavior, and sustainable finance.
Which is that it's about growing the pie, actively creating value for society.
So we need to find ways to help ourselves sort of think beyond what we're used to, what's familiar right now.
How can we create this capability to thrive amidst continuous change?
China is about the most creative when it comes to green finance policy, rapidly innovating across asset class, trying to do more and more.
Welcome everyone, and thank you for joining the first edition of our Responsible Investing Summer Course 2021. Our summer course is a think tank initiative held in collaboration with leading academics from universities across the globe. My name is Jeroen Bos, and I'm head of specialized equity and responsible investing at NN Investment Partners, and I will be your moderator today. For those of you joining us for the first time, our summer course this year focuses on the future of responsible investing and is an interactive series that builds on the success of our summer course last year. Leading academics from all over the world will deliver a series of virtual, interactive lectures about the future interplay between sustainability, finance and technology, starting today and running until the 25th of August. Topics that we will touch upon during this summer course will include questions like: how can we be sure that investments not only generate attractive financial returns, but also have a positive impact in the real world? How can we ensure the business models that are being developed address issues such as climate change, biodiversity, the circular economy, and other social challenges? Do technologies such as machine learning, natural language processing, and artificial intelligence in ESG really work? And what is its future? So plenty of interesting topics that we will explore in the coming weeks. Before we begin today's session, just some quick housekeeping. This broadcast is not only live, it's also interactive. We welcome your questions for Professor Caldecott in the chat, and if you run into any technical difficulties, please use @NNIP Helpdesk, and we will do our best to resolve any issues. With the logistics sorted, let's dig into today's session. Let me welcome Professor Ben Caldecott, Director of Oxford's Sustainable Finance Program and Professor in Sustainable Finance at the University of Oxford, joining us today live from the UK. Good to see you, Ben, and thanks for joining us. How are you today?
Very well. Sweltering in London a bit, I must admit, but wonderful to see you, and thank you so much for the invitation to join.
Great. Well, really looking forward to your presentation and learning more about spatial finance and how space technology and data science can actually help transform decision-making in finance and investing. So I will join you again after the keynote for the Q&A. So over to you, Ben.
Great, thank you. So as a very kind introduction, so what I'm going to be talking about today is spatial finance. So how space technology and data science in combination can transform decision-making in finance and investment. So hopefully you can see my slides, and what I'm going to do is go to the first slide. So what I wanted to start off with is really actually saying a bit about how, in general terms at a high level, how environmental risks and externalities are measured at the moment, the way in which we need to change that, and then I'll talk a bit about how space and artificial intelligence, data science can help us resolve these problems and realize a much more transparent financial system that will enable a whole range of different, very valuable and important use cases, many of which, not all, but many of which are related to sustainable finance and investment. So currently, and this is a bit stylized, but there's, I think, a lot of truth in this, is current efforts disproportionately focus on essentially understanding the carbon footprint of, or carbon intensity of companies at the parent company level. So you have a company, that company is exposed to a whole host of different risks, some related to physical climate change, some related to carbon pricing, some related to competition from different technologies, different forms of reputational risk. That's a whole other lecture. But suffice to say, there are a lot of things related to climate change, related to the environment, that are going to affect the value of that company now and in the future. So what's been perfected as best as is possible is, okay, well, let's take the carbon footprint of that company. And we're going to use that as a bit of a proxy for all these different things. And surely that's the solution. Now, obviously, it's not the solution, as you can tell from my tone. And even if it is a solution to any particular problem, one of the challenges is this data is just not very good. So you have some companies that disclose, some are required to disclose because there's mandatory disclosure in some jurisdictions for listed companies or large companies. Other large companies or listed companies will voluntarily disclose. And so you have a problem with coverage. Not every company is forced to disclose or will disclose. Most of the companies that do disclose are large listed companies. Most of the companies on planet Earth are actually non-listed companies, so that's a bit of a problem. And then a lot of the disclosures themselves are inaccurate. Zeros are added or missing, or they're measuring emissions from the HQ, not the full operations. You know, if people that spend time, many of you, I imagine, on listening to this will have done this before, but getting into the detail around how these disclosures, the quality of these disclosures so you can use them, you find all sorts of mistakes. And by definition, these things are backward-looking. So when something is disclosed, by the time it actually is included in the data set that you're looking at, it's kind of out of date. And then for the companies that don't disclose, what is done is that those carbon emission numbers, intensity numbers are then estimated using different black box methodologies. And we don't really know how accurate some of these are. It's very hard because they're black box methodologies, and people don't want to share their secret source. But that in some ways, that's quite problematic. I think that these are non-transparent black boxes. So that's, we're spending a lot of time over the last decade. This approach has received an awful lot of attention. Now, in my view, what we need to do is something quite different, and we need to, instead of looking at just carbon emissions and carbon intensity, instead of just looking at the parent company level, we actually need to go down a level. We need to go to the assets that companies own, and we need to stress test each of those assets. And what I'm talking about here is mainly physical assets, but actually the same principles I'm talking about can apply to intangibles as well. Obviously, from a climate change, sustainability, environmental perspective, the assets that are really troubling for the environment are physical assets. So you want to take each of these assets. Each asset is exposed to these risks. These risks vary, they differ by location. They're inherently spatial. And then you aggregate the results. If you know who owns the assets, you can aggregate that to the company. And of course, you can aggregate all that up to a portfolio, because a portfolio consists of companies. So you're measuring these things, and you're also measuring them accurately. You're measuring, if you care about different aspects of physical climate change, then you should be measuring heat stress, you should be measuring flood risk, you should be measuring wildfire risk, and so on and so forth. And similarly, if you're interested in climate-related transition risk, what are the things you should be measuring, and so on and so forth. And this is really the heart of the transformation that is enabled by spatial finance, the integration of geospatial data and analysis into financial theory and practice. So putting this into a bit of a framework quickly, in my mind, there are a number of bits here. The first, it starts with this asset level data. You need to know where the assets are. You need to know who owns them. You need to know their characteristics before you can do the aggregation, right? And so we need much better data about where the assets are, who owns them, where they are in the world, and we need to do that sector by sector. You're then putting the asset into this analytical time machine, and you might be linking that to scenario analysis. You might be seeing how it's going to perform 30 years in the future in relation to some sort of physical risk. It might be nearer term analysis. And I should have said, the approach that I was outlining here is not just about risk, it's also about externalities. So individual assets have an impact on the local environment, on the global environment, for example, through greenhouse gas emissions, and on society. So if you're measuring things at an asset level, you can also measure the positive and negative externalities that assets are having. So you can do the same thing, not just for risk analysis, but also for impact and externality measurement. So that's the first three things of this 5-part diagram. The fourth thing is really where I think a lot of disclosure efforts really add the most value, actually. So how, you might have two companies, company A and company B. Company A and B have the same amount of risk exposure, but company A might have a plan. It's got a CEO and a board that really believes that it needs to tackle these issues. It's exposed to these risks. It's going to change its business model. Company B, not so interested. So how do you tell which company has better management quality characteristics? You might do that through disclosures. It might be represented in their TCFD disclosures, their Task Force on Climate-Related Financial Disclosures reporting. And you could say, okay, well, company A is better than this than company B, and that's going to have, they might have the same levels of risk today and into the future, but this company is going to change and therefore lower its risk. And then, of course, you've got to turn all of that into, what does this mean for valuation? What does it mean for credit risk? What might it mean for economic models that you use? And at Oxford, where I'm based, we're very focused primarily on the first three aspects of this 5-part chain. I think the fifth part is very much for financial institutions themselves, because financial institutions have different risk models, different valuation models that are tailored to their specific requirements. And the fourth thing is in part about, again, this is in part about the asset management community. It's about the banking community providing finance. It's for insurers to determine to what extent a management action is actually going to affect risk and resilience. So I'm going to show you some examples now, very simple examples. You can sort of see how quickly, there's so many different things you can do. And this is, and the following slides are focused on the EU. We can do this for different jurisdictions. We can do this globally, but just as a sort of a zoom in, this actual slide probably would have been more exciting if it was South Asia or Southeast Asia. So forgive me that I don't have that slide. But essentially here, what you've got is a set of hypotheses, which are, I think, quite reasonable. This is for the power sector. So power stations, coal-fired power station, gas-fired power stations, other forms of power station. And the view here is, look, if air pollution is a driver of political and regulatory concern that can result in retrofitting obligations, it can result in curtailment for power stations, it can result in premature closure of power stations. People care about air pollution. Power stations can contribute to making air pollution much worse. So if you've got a big power station and it is near a population center, and it's near a population center that already has a lot of air pollution, all things being equal, those assets might be more at risk of becoming devalued in some way because of those concerns about air pollution. So where are those assets? Where are they located? And the reason I said it would be more relevant in South Asia and East Asia and Southeast Asia was that air pollution is a much bigger issue in those emerging economies, although it is still a big issue actually in Europe. So you can then go, okay, well, company A has more exposure to assets that might be devalued in some way because of air pollution than company B. That would be a very simple thing to do. This is moving on to physical risk. So this is acute drought risk. There are different ways of measuring acute drought risk. This is just one way. Looking at 2030, number of consecutive dry days. And this is under business as usual. So if we don't do anything to tackle climate change, Mediterranean basin, lots more acute drought risk. You can then again look at the companies, and you can then look at your portfolio. In our portfolio, how many companies do we have exposed to drought risk? Because power stations need water to cool themselves down, right? And this is under 1.5 degrees. So you can see the difference between this is taking action on climate change. This is not. Risk exposures change in these future states. Let's have a look at the companies that are exposed. You can also see one of the challenges with some of this work, which is here you can see the coarseness of the data set. The resolution here is very coarse. You see the squares. And this is a coarse global data set that's publicly available that we've used. And so there's a question, okay, well, if you're interested in acute drought risk, what are the best ways of measuring it? You know, if you've got assets in Portugal, and you can see here there's quite a lot of risk in Portugal, maybe we should be using a much more high resolution data set to measure those risks. Maybe there's a local set of projections and models that can be used to much more accurately determine localized risk exposures than just using this rather coarse global data set. So one of the challenges is choosing the right measures for the different use cases. And this is another example. This is carbon capture and storage. A lot of institutions, companies often say, "Oh yes, well, you know, we've got all these fossil fuel assets, but look, carbon capture and storage. We're going to plug this in to CCS, and it's going to store the carbon, and that's going to be fine." Okay, I mean, I have some serious caveats, issues, questions about that. We can talk about that another lecture. But just the basics, you know, you're not going to retrofit or be able to retrofit a power station that is far away from geological storage. You're not going to really be able to retrofit a power station that's a really old one. Why would anyone retrofit a really old power station with something that's really expensive? And you're probably not going to retrofit small power stations because, you know, economies of scale matter with these retrofits. So we just apply some basic filters here. You can change the use of sensitivity analysis using these parameters. But you rapidly see that there are only actually a few places in Europe where this is viable. Based on those assumptions, you can change the assumptions. Maybe it's more assets than here, or maybe it's fewer. But the point is, in the past, what policymakers had done was they just assumed that you could do it everywhere. But you can't. So if an Irish or a Spanish or a Polish company goes, yeah, well, we can do CCS. Based on these assumptions, it's hard to see how they could. Now, again, maybe the assumptions are wrong, but this could be an engagement device. It's particularly interesting to see in the US, lots of US companies claiming they can do CCS. Again, we've done this analysis for the US, and you can see that many of them probably can't. And as investors or lenders to those companies, these are sort of questions you should ask. This is heat stress, business as usual, 1.5 degrees. I'm using the power sector because we have good asset level data. I'm going to tell you a bit more about other sectors where we have good asset level data. And this is different things you could do with biodiversity and nature. This is all very rudimentary stuff, but just to give you a sense of the sorts of things one can do with asset level data, bottom-up approaches. Approaches grounded in spatial finance. Now, you might think this is sort of slightly the wrong way around, but there's some logic in why I've taken it this way around. So now I want to talk a bit more about specifically spatial finance, some of the challenges, the opportunities, the use cases beyond the things I've talked about in the last 10 minutes or so. So spatial finance, I've mentioned the definition already, but it's the integration of geospatial data and analysis into financial theory and practice. And as we'll see, it has a number of different use cases. I think there's definitely, if you do the Venn diagram between spatial finance and sustainable finance or green finance, there's going to be a lot of overlap because, as I said before, pretty much every environmental or climate related issue is in some way geospatial. However, the applications of this are much broader than just sustainability. So yes, it can provide really important capabilities for greening finance, greening financial decisions, but it can also provide data analytics that are useful for a whole range of different types of financial analysis. Bear in mind that finance today doesn't really have very much anything to do with geospatial in it, really. You know, valuations are not really tied to any form of geospatial analysis. And so I believe that adding this dimension, making finance and financial analysis kind of 3D almost by adding these capabilities can provide really important insights to valuation, investment analysis, and so on. And this has been driven by a number of factors. One key driver is technology changing, particularly in terms of Earth observation constellations of different kinds. This shows you the number of satellites, small satellites being launched, CubeSats, size of a shoebox. You have constellations of these run at the moment, for example, by Planet Labs, based out of California, 200, 300, maybe even 400 satellites in sun-synchronous orbit, taking high-resolution pictures of the landmass of planet Earth every single day in different spectral bands. And this has been going on for some time now. And you've also got, in addition to these small CubeSats, you've also got public constellations funded by NASA or the European Space Agency that are, again, taking complementary imagery, again in different spectral bands, different resolutions. And it means we're collecting more imagery, more information about the planet from space than ever before, and this just keeps growing exponentially. And the exciting thing that has been enabled by other advancements in technology is artificial intelligence and machine learning. So can we train, well, we can train algorithms to identify changes through that imagery, as well as to define, in this case, this example from a project is to identify iron and steel plants and their characteristics, and cement plants and their characteristics through Earth observation and machine learning. So other examples, one of my PhD students, for example, has just finished, but has spent a lot of his time focused on identifying where solar photovoltaics are in the world, around the world, using public and privately available satellite imagery, training a machine learning model, applying that to that imagery, and then identifying where these assets are and where they're being deployed, where they're not. So you can, in theory, literally, it's a bit more complicated than that, but you could go, Siri, tell me how many solar panels have been deployed on planet Earth in the last week, and the answer can be provided. Obviously, the computational resources required to deliver that kind of answer at the moment are a bit sparse, but that's the kind of thing that is technically possible. So it's that combination: more sensors, more data capture platforms, collecting information around the world, and then the processing of that using machine learning, because obviously it's just so much imagery. Teams of people just couldn't process it for it to be in the pace that would be useful. So I've mentioned asset level data, and that's critical because you need to know where all the assets are in different sectors. You then have other observational data sets you can overlay onto that asset data, and that could be hazards of different kinds, physical risks. You can measure externalities, how are these things contributing to local environmental pollution, deforestation, all of these things, and you can aggregate that up to companies and then to portfolios, and of course for the whole economy if you want to. And then people can build products and services on the back of these data sets. So that's an area where we are trying to enable innovation, commercialization through something called the Spatial Finance Initiative, which is part of a new UK Centre for Greening Finance and Investment, which I direct. And this is going to be, I think, super exciting for enhancing capabilities across finance. Now, I mentioned there might be some gaps in asset level data, and that is a key problem. So you can see here this chart showing where do we have asset level data, where don't we have it. This is organized by the emissions that are created. And for the power sector, we have good levels of data. We've just published last week, as part of the Spatial Finance Initiative, global asset level data sets for iron and steel and cement production, which means for the first time that people can do very detailed asset level analysis for those very polluting sectors. They each contribute to about 5 to 6% of global emissions, each sector. And then there are a whole bunch of other sectors where we have partial data. Some of that data is, sometimes the data exists, but it's in a kind of a mix of different locations. It could be in a variety of proprietary data sets, but sometimes it doesn't exist at all. So the challenge here, particularly from a finance perspective, from a finance use case, but also for other users, is you don't want to have to patch together, dozens of different data sets with different subscription models before you can use this stuff. You want to be able to get this stuff and easily, cheaply make sure it's trusted, consistent. So what we're trying to do with the Spatial Finance Initiative is really a large public goods initiative to try and make asset level data for all the sectors on planet Earth freely available for commercial and non-commercial purposes. So we've got a trusted view of where all the assets are, and then you can start building products and services on the back of them. So there are a variety of different use cases. Now, some of the current use cases where financial institutions are using Earth observation data and AI are relatively niche, and they're things like, let's see how much coal is in a port in Australia, or how much oil is stored in all storage facilities in China. And that gives you some insight into the future of commodity markets and commodity pricing and commodity prices. And that means, obviously that's important for commodity traders, and they can make bets based on that information. You also have insurers doing, ex post disaster assessment around insurance claims. You have use cases around macroeconomic projections. Let's fit an economic model based on number of people using shopping malls in the US. How many people parked in shopping mall car parks last year or last quarter, and what does that tell us about inflation or GDP figures before statistical agencies produce those data sets. But the use cases are much broader than that, and they extend beyond finance. So these are some of these are sort of broad. This is from a report also that came out last week from the Spatial Finance Initiative, looking at potential market size of different types of use case, and where they are in their state of maturity. So they're just being introduced to their growth stage or their maturity. So you can see some of the catastrophe commodity trading stuff is relatively mature. And then you've got things like, real estate due diligence, agricultural products tied to Earth observation imagery. And then you've got these sort of more emerging things, which is what we're working on at Oxford around nature-related, environment-related, climate-related risks of different kinds. I would actually argue that now that I see this on the screen, that the market estimation might be bigger for some of these actually than they're represented on the chart. So it's very much a emerging area. Now, I mentioned the work we've been doing on global public goods and the publication of these cement and iron and steel data sets. So this is the process we've just gone through for the last 18 months to prepare these data sets for publication. Let's identify the assets, let's characterize them using a variety of different data sets. Let's annotate them so we can do subsequent analysis, and then you end up with a global data. Obviously, it's more complicated than that, but running out of time. But you end up with these data sets going, okay, well, we can estimate the production of these assets. We know where they are. They're precisely geolocated. You'd be amazed how few assets in most sectors of the global economy are properly geolocated on a consistent basis, and that is a fundamental prerequisite for any form of geospatial analysis. This is the same thing we've done for iron and steel assets. And some key takeaways. The technologies here are only going to get better. The data availability is only going to get better. That's going to result in more commercialization, more use cases. And essentially what we will do through the Spatial Finance Initiative and other things is essentially sequence the real economy. So we'll all know where assets are, who owns them, what their characteristics are. And that will enable all sorts of analysis beyond just that related to climate and the environment. Because if you can see what companies are doing without them disclosing, often in near real time, that is going to help with everything from investor engagement through to better pricing of risk and better due diligence, amongst other things. So I will stop there. Hopefully that was interesting, and happy to take questions.
Thank you, Ben. That was great. A lot of valuable insights. And as an investor, always looking, of course, for new and better information. And this looks really promising. So moving on to the Q&A. So for everybody in the audience, you can post your questions through the chat function. And while we wait for those to come in, let me kick off with the first question. So, Ben, aside from, let's say, supporting the fight against climate change with better environmental insights, how do you see spatial finance evolving to tackle other ESG-related challenges, more on the social side as well?
Yeah, great question. I mean, I think just sort of taking a step back, I think the really exciting thing about this is the use cases are so broad, right? So I think I'm always fascinated. You know, you talk to people and they go, "Oh, you could use it for this and that," and you haven't even thought about it. So these particularly on the asset level side, you know, these are enabling data sets that allow people to explore a whole range of questions that they're interested in. So in terms of supply chain relationships, for example, this becomes very important. People are using geospatial data and AI to identify slave labor, the use of slave labor on ships off the coast of Africa, for example. Now, what's the finance use case there? Well, there's anti-slavery legislation in a number of jurisdictions, and so you know that's the sort of thing that's going to help with due diligence. So yeah, I think there are a whole range of different use cases. I mean, obviously there's some things, many things, that it's going to be very hard to determine from space. So I'm not saying that this is, you know, the solution to everything. I'm saying that it's a really important potential contributor and another bit of the toolkit that currently, you know, isn't being used very much at all. So yeah, hopefully that sort of partially answers the question.
Yeah, clear. Thanks, Ben. A lot of questions coming in through the chat. Maybe a first one. Do you think spatial finance applications could support business responses to the environmental catastrophes that we saw recently, like the flooding in Germany, Belgium, and the Netherlands, for example, in recent weeks?
Yeah, no, well, absolutely. And I think there's, you know, understanding the exposure to these hazards. I think there's also one interesting component to this as well is using these capabilities to better understand vulnerability. You know, what is the capacity of infrastructure to deal with these physical events? And also, what are the interdependencies? So, you know, how does one system relate to another? What are the transmission mechanisms? Are there cascading, reinforcing risks that we need to understand? So these sorts of approach combined with predictive modeling of different kinds, systems modeling, digital twins, something else people do a lot of work on, can help answer these questions. So again, it's geospatial data analysis from these new sources combined with a number of different things then generates the really valuable insights that are going to help answer and solve some of those big questions around physical risk.
Clear. Question coming in from Tariq Abbasi. Question is, a good level of data is even a problem for sustainable finance as is not a regulatory requirement in general. Do you think the regulatory requirement needs to be developed more effectively in parallel with spatial finance?
Yeah, so I mean, one thing I've argued for 5-6 years now, I think at least, is is a principle of asset level disclosure. So, in disclosure regimes, we should be asking for asset level information to be disclosed. Now, what happened when we suggested that into the TCFD at the beginning was companies lobbied against that. They went, well, that's commercially sensitive information, and that's unacceptable. And I think that's overdone. I think there is a way in most sectors for relevant asset level information to be disclosed that protects commercial sensitivities, but also means that we have much better information to do this sort of analysis. And I mentioned, just things like coordinates, basic stuff that's actually missing in the system. The other, so that's one thing that could be introduced. I think one other driver of this, one other reason I'm very passionate about it is, I don't think disclosure is going to solve the data problem. I mean, I have so many conversations where there's deep confusion between about what disclosure is all about. People seem to think that TCFD, these disclosures, are going to provide the data that's going to actually enable the sorts of analysis we need to see happen in the system. It's really not, because the underlying data is not disclosed. It is a version of what the company thinks. It's backward looking. It's the best version of the company because it's gone through the marketing department, the investor relations department, and so on and so forth. It does provide, as I said, that insight into management quality, potentially. But if you need real observational data to do analysis, you ain't going to get it from disclosure. So we need to, and we're not going to get all these companies to disclose all of this stuff either. We might get some of it. So we need a solution. What's the solution? Well, thank God we've got these investments, public and private investments, in Earth observation, in machine learning capabilities that can allow us to get the answers without having to rely on slightly biased companies. And it resolves the need, resolves issues around listed, non-listed. You have genuine global coverage. So we should be, if 1/100th of the effort had been invested in spatial finance, as has been invested in the TCFD over the last 5 years, we would be in a much better position in terms of our understanding of what's going on in the real world and how that's relevant for financial decision making.
Clear. And maybe as a follow-up on that or related to those investments, a question from Michelle Locatelli. Do you think the climate consciousness is gaining mainstream? Space could basically suffer also a bit of a bad reputation and suffer a limitation with high-flying billionaires basically going into space, where you have some discussion around the emissions that is causing as well. So what's there the trade of your thoughts, I think, around that is the question.
Well, that's a very good question. I mean, I don't have a great answer to it. Obviously we need to be minimizing, eliminating environmental impacts that we can have. I mean, I think, though, for some of these Earth observation capabilities, you can launch dozens, if not, several dozen of these satellites in a single launch. And admittedly, they need to be deployed again and again because they don't stay in orbit for particularly long. But I think but if anything, this puts greater onus on us using these insights, using these data sets in a way that can help society become more sustainable. So I would rather we focus on some of the use cases I'm talking about than perhaps some of the others.
Clear. A question as well, more on the insurance industry. So can you give some examples? How are these tools basically used, or maybe not, by insurance in their pricing models in terms of underwriting risk and so on?
Yeah, so insurers on the liability side, one of the kind of more mature bits of finance that have been using these capabilities to price risk and assess claims as well. So I expect to see much more of that. I would just say, so just looking at the chat, Nathan's question, whilst I spot it, is a good one. But so essentially what we're trying to do, for example, with creating these global publicly available asset level data sets, is totally to address that. So, I mean, yes, some of the imagery from privately owned satellites or private sector companies will be owned by those companies. But if you're creating derived data sets from those images, whether the images come from public investments or private capabilities, those data sets can become public. So it's not quite as simple as just going, well, some of the imagery is private, therefore it's all in the private sector and can't be used by the public. It's, you know, we can use private data to create data sets that can be public, and that's what we're trying to do. And that is I think the key intervention that is needed to unlock a lot of these applications.
And maybe then on the quality of data, question from Mark Griffiths. What about the verification of space data? Are you seeing new standards evolving, and do you feel standards are needed around that?
Yeah, I mean, it's a good question. I mean, I think one of the nice things about this area is that, you know, it's really robust observational data. So there isn't the, you know, you're kind of missing out. You're sidestepping all of the questions about data quality that you often get with any other form of disclosed information. You know, you know whether the imagery is genuine imagery and all the rest of it. So, I mean, I think there's for me, standards. I mean, there are a number of different aspects to standards in this space. I think there's sort of maybe soft standards that I think need to be created around what's the right way of using this data and information for what use cases, what's it useful for, how should people be using it. So those are sort of like practice standards, I guess, norms around how you use stuff, and also skills. You know, how do we make sure people are using this stuff day to day? You know, at the moment it's very specialist area. How do we make sure everyone that's, you know, every CFA is competent with spatial finance by the end of the decade? You know, can we do that? How do we integrate that into professional development, core curriculums, continued professional development? So I think these are really interesting questions. Some of that's going to be enabled by software that makes it easy. You know, I sort of, you know, this is, I think, a very important layer to the financial data, basically, and the financial data market is very big. Who's going to capture that additional slug of value? You know, is this an opportunity for disruption? You know, is the Bloomberg terminal the thing you're going to be using for geospatial data? Question. You know, is this something Google could you know, disrupt? These are all open questions I've raised many times with those companies themselves. It's going to be very interesting to see how they react to this, and some of them are reacting obviously at the moment and investing in capabilities. But it'll be very interesting to see.
Clear. And then maybe you have done a lot of work in this area. That's clear also from all the examples you showed. How easy, you talked about barriers, how easy is it for you now to get asset level data? And do you have any tips for investors to more easily get their hands on this data to do those analysis as well, and increasingly integrate this into their analysis?
Yeah, well, you know, the big impediment, as I say, for doing analysis is asset level data for different sectors. At the moment, you can't do that for every sector, or it'd be disproportionate to do the work, I think, to do that. So we have a collective interest in increasing the number of sectors where we have coverage. We will be, in addition to cement and iron and steel, we are beginning work now on pulp and paper, on petrochemicals, on the waste management industry, on industrial agriculture. These are all being funded actually by philanthropy, mainly. And so you know, that data will be available as soon as possible, as soon as we can do the work. It'll be updated. It will enable people to do new analysis for those sectors. But I would start where you have the data. So start with the power sector, start with cement, start with iron and steel, start with shipping, start with aviation. And, for a long time, we're going to have to do, for some sectors where we have data, we'll do this bottom-up, much more sophisticated stuff that I've just talked about. For some sectors, we don't have the data, and it'll be the top-down, more traditional approaches for some time. So get the practice with the sectors where you've got data, build up the capabilities into other sectors as other data sets become available is what I would recommend. And of course, support. Of course, this is where it's the self-interested pitch. Support efforts to make consistent asset level data available, because that grows the pie for everyone.
Yeah, clear. Maybe a related question to that from Marco Leijs. From a practitioner, basically, the main problem he is facing working with spatial data on a central bank is not necessarily locating the asset data, but basically finding the appropriate hazard maps to measure the risk and link that. So shouldn't that be the main focus as well of these initiatives, like, for example, TCFD?
Yeah, it's definitely a complementary thing. I mean, I think there are a number of initiatives that are starting to try and make different hazard layers available, including my one, the one that I direct, the Centre for Greening Finance Investment. But I know this is something that OS Climate, for example, is working on. There are others too. There's another name I've temporarily forgotten, but it'll come to me. So yes, we need to make that available. I think it needs also to be combined, which is really a lot of our focus at Oxford, is people are using hazard layers and projections in all sorts of ways that are not appropriate. So in addition to making these things available, we need to ensure that people are using projections, hazard layers in a way that's informed by the science. So, I'm not a climate scientist. I hang out with climate scientists occasionally as part of the centre. Climate scientists I speak to are shocked at how global climate models are being downscaled and used for what seem to be very precise physical climate risk assessments that just are not possible given the type of modelling and what the models are designed for. So we need a much more sophistication in how these data sets are used, and that isn't all down to users, it's down to data providers, it's down to the academic community. We should be much better at communicating confidence levels with data sets. We should be much better at being clear about what data sets can be used for, what they can't be used for. So we're going through a process of trying to make some of these hazard layers and projections more useful by adding that kind of information as well. So it's not just the hazard layers, it's also how the hazard layers are actually used. And they need to be used appropriately to get the results that are going to be helpful to make better decisions.
Clear? Maybe a question, and I'm not sure how familiar you are with the Moody's 427 data set, which is a physical risk score. So the question here is, how would spatial finance initiative data, could that provide additionality to that other data set?
Yes. So, you need the asset level information to do the physical risk score at an asset level, right? So, that's why these guys are very happy that we're producing free asset level data sets that can be used for commercial purposes because it improves the quality of their product. That's the whole point. I think in terms of the physical risk scores, I mean, it kind of echoes what I was saying before. We need to be more transparent about what these projections can actually tell us at that level of granularity on physical risk in particular. And I think, one of the challenges for these guys, there are multiple data providers in the space, is that tension between transparency and, having a proprietary product that you need to make money on. So I'd just say that I don't think we're at quite the right, we aren't there yet on physical risk in terms of quality, transparency, all this stuff. And it's not a particular dig at anyone, it's just a general observation, and it's difficult, it's not easy. So we've got to work collectively to solve these problems.
Yeah, question then on basically the regulators. So the question is your team working with the regulators to really leverage the insights you are generating to support the sustainable development?
Absolutely, across the board, we spend a lot of time working with central banks, with supervisors, with policymakers, with governments around the world on these issues. And it's really important. And in fact, before speaking here, I was finishing up a course for 300 policymakers, supervisors that we've been delivering basically for free or a very heavily subsidized rate, funded by philanthropy, because those actors need to be aware of these issues. They can shape the future of these markets. They're critically important for dealing with everything from greenwashing through to risk pricing, through to capital requirements, through to new products, new instruments that can enable capital to flow into solutions to climate change. So, this that's totally critical to work with those actors. And in fact, you can't green the global financial system. You can't deal with these issues unless there's a lot of involvement from those actors.
Yeah, clear. Then another interesting question, this one from Samuel Aka. How do you actually deal with privacy and consent when it comes to corporate assets and the spatial data?
Yeah, that's a really good question. I mean, I think you get into well-trodden issues around, particularly for individuals. We aren't doing anything that is related to individuals. On corporates, I mean, it's going to be, there's some really interesting ethical issues as well, I think, with some of this. And not being an ethicist, I don't, I've colleagues think about these issues and they're very important. But for example, if you can use these data sets to identify things that might happen in the future, right? So you can use Earth observation capabilities and machine learning models and predictive models to figure out which tailing dams are at risk. If you're really, a bad actor, you could use that information. You could get that information, not tell anyone, and short a company before a tailing dam accident happens. So there's sort of ultra transparency of this kind, particularly when there are asymmetries of information, can cause issues. I mean, I know a company that is doing great work, but they, I'm sure they've debated these ethical questions. GHGSat, which has got methane monitoring satellite constellation, a small one. They're trying to sell their data. If they see that a company is emitting, do they go to the regulator? Do they go to the company? What happens if the company doesn't pay them? What do they do? So, and I'm sure they've got a good answer, but it's some interesting ethical questions there.
Yeah, clear. A couple more questions coming in. Let me see. Shouldn't, let's say, this be a discussion as well for the COP in November? These data sets and the discussions around that, or is that maybe already part for COP in November?
So, I think transparency is really important for all actors, really, in terms of tackling climate change and enhancing resilience. So, what data is required, how should it be made available, in broad terms, is definitely part of that UNFCCC process and one of the topics that comes up again and again. I certainly think that, personally, instead of a university and a couple of institutions trying to sequence the real economy in a way that's analogous to the Human Genome Project, I like to think, let's sequence all these assets. It's sort of similar type of endeavor in a way. It should be a globally coordinated effort. So I personally would love to see governments funding this, organizing all of this in a really coordinated way, so we can sequence the real economy really quickly and unlock all of these use cases really quickly instead of doing it at a much slower pace because we have to rely on philanthropy and the odd bit of funding here and there. And so there's definitely a good public goods case for governments to do more.
Clear. And I see the positive case for increased transparency. A good question from Bianca Taylor. Has there actually been any pushback from the intelligence community? So Chinese, US, European governments actually trying to prevent some of the work and transparency you are trying to create?
Not yet, not directly, not with our work, but you know, I mean, I think there's if you get to a situation where you're another direction for all of this is, you know, if you've got ultra transparency on emissions, so, you know, we can see who is emitting, where they're emitting, whether they're meeting their promises or not. You can definitely imagine some state actors not liking that. Because, you know, that you can see when somebody is not meeting their commitment. So I think we probably will see efforts to frustrate it. I mean, there are already efforts to frustrate that in a Chinese context. The Chinese government does try and prevent all sorts of satellite-based analysis, and we'll see more of that, I suspect.
Okay, maybe a final question. I see we have still a lot of questions coming in. We might try to tackle them after this session. But maybe for a last question, do you have any final advice for the audience today on how to best use what we discussed today to improve both the ESG integration side of things, as well as improve the positive impact we can make on the environment and society?
Big question. Look, I mean, I think one of the beauties of this, I didn't really have time to hammer home the point, but I will now, is you can use the same data sets or similar data sets to do both risk analysis and externality analysis, which means externality analysis is the same thing as impact reporting, right? So when financial institutions or companies have done impact reporting in the past, they don't use the same data sets that they use for risk analysis. They invest a lot more money and energy in data sets to do risk analysis because it's fundamental to the bottom line. Now, imagine a world where you've got really high quality data being used for impact reporting, and it's the same data that's being used for risk analysis. It's going to dramatically improve our ability to see the positive and negative contributions that companies and portfolios are making to big environmental and social questions. So I think you know, in terms of your own institutions, wherever you are, whatever you're doing, think about how this can solve a number of different reporting and analytical questions for you, because it can. And the more of those you identify, the stronger the business case, and the more likely it is your bosses or whoever is responsible for those decisions will get on side and support these efforts. And of course, it's a long-term secular trend. You know, this is not going to go anywhere. Capabilities will improve. You need to invest in people, in capabilities now, so you can yield the benefits in the future in the next few years.
Great, thanks, Ben. And I'm afraid this is all that we have time for today. Really enjoyed today's session and then the passionate way you brought this topic to life. So very confident the audience enjoyed it a lot as well. So thank you very much, Ben. From my side, I would like to thank you all for joining us again today. We hope to see you again for the next lecture that is scheduled for the 28th of July by Professor Nancy Kamp-Roelands, Professor Non-Financial Information, Integrated Reporting and Assurance from the University of Groningen. And she will talk about how transparency can have an impact on value creation and can support responsible investing. For now, wishing you all a good day or a good night, depending on where you are in the world. Thank you and goodbye.